Hello everyone, and welcome back to Technically Unsure, where I'm not really sure what I'm doing technically,
but I know I'm doing it really well.
So today we are going to take a look at a completely different type of SBC. So we have been looking at Raspberry Pis, RK3588, RK3588S, and that type of SBCs. I just heard about a company that honestly I haven't heard about before. This company is called PolyHex, and they apparently been around for a while, and they are setting up even more R&D centers, growing basically. Seems like they started a new R&D lab in Wuhan 2021, and they have their own factory for building the boards and devices, and they have lots of ISO certification. These are stuff that I was checking out their about page. That's where I was seeing these things. Apparently also they are part of the NVIDIA Inception program. Anyway, so this company is making industrial SBCs for a while. So the board that I'm going to review today is their latest release. It's coming out and it's called the Debix Model C. So this board, which is right here, so this board is not using RK3588 or Raspberry Pi processor or anything like that. It's not one of those processors that you've seen in common SBCs that are out there and you see people are using. Those are all consumer grade processors and SBCs. So Debix Model C on here uses NXP i.MX 93 processor. This processor is specifically designed for industrial IoT and like automotive applications and things of that sort. Like unlike consumer grade processors, the consumer grade processors usually does not really care about harsh environment. So these industrial processors prioritizes optimizing performance and power efficiency in demanding environments. So the i.MX 93 processor right here is built to handle like heavy workloads in fluctuating temperatures. That usually you see that in industrial settings, and the device needs to be on 24/7 in like outdoor environments. Sometimes temperatures can go freezing, sometimes it'll go up to very high temperatures. So these are not consumer grade processors. You can use it as a consumer, but these are usually industrial, deployed in industrial applications. And this processor is also part of the what they call longevity program, which guarantees that this processor will be produced for 15 years. And this one can withstand a lot of harsh environment and temperatures, as I said. So this board that I'm holding can work on -20 Celsius up to 70 Celsius. This version. There is another version that can go -40 Celsius up to 85 Celsius. Yeah, so this can work in, as I said, industrial environment. Can take all sorts of abuse. So full disclosure, PolyHex sent this board to me, okay? But I gave them in the same treatment I'm giving everyone. As soon as I get anyone contacting me, I tell them, you just send me board. If you let me buy it, I would really prefer just buy it. That's what I did with other couple of things that I reviewed, right? I just straight up bought it. So this one, they sent it to me, and I can see even like flux residue. So it's not even out yet, but it is going to come out very soon. This is the Model C. The A and B is out, but this is Model C that's coming out. So let's take a look at this board, okay? So let me flip it over. As you can see, it does have two 1 gigabit Ethernet ports and two USB 2 ports right here. There is audio jack 3.5 millimeter right there. And this one is MIPI CSI, this one. And this one is USB OTG, USB-C OTG, and this one is USB-C power. So this one is used only for power, and this is OTG. If you look, there is the 40-pin Gpio right here, which I am most interested in. That's industrial application, right? So I want to see the PWM signals, I want to see Gpio pins, and I want to see that those are documented, hopefully. They told me about a command that I have to run, and it supposedly tells me all about it. I really hope the command does have a very good -- help, some information in there, because they didn't share any syntax information, but I'm going to check. These pins in here are LVDS. That's for connecting the screen, but from what I read, what I see in their documentation, seems like it just works with their own screens that they sell. So I'm gonna skip that. There is the LED stuff in here. This is MIPI DSI. So display, MIPI DSI, MIPI CSI camera over here. And there is a toggle switch. So those are for, as you can see in the explanation right here on the screen, to boot from USB device, eMMC, TF, USB TF is the flash SD card. The last one says NOR, that I honestly don't know what that means, but yeah. So that's pretty much it. So this is Debix. As you can see, that's the label. The CPU is really hard to read. I can see it with my eyes. I have to put it under a microscope. But yeah, that's the processor. It's very small, but we'll see the performance. So on the back, I already downloaded the Ubuntu image they sent to me. I plugged that in. I just burned it to the USB and I put it in there to get ready for this video, and nothing else is in the back. Okay, so give me a couple seconds. Let me plug everything. I'm gonna put an Ethernet, mouse and keyboard, which honestly I don't think we need because there's no display, as you have noticed. So I'm gonna SSH into this thing. Yeah, I don't think I need a USB. So what I'm gonna do is Ethernet, SD card is already there. That's it, and the power. Okay, and we are gonna also monitor the power consumption. So give me a couple seconds, set this up, and then I will SSH into it and we take it from there. I will be right back. Okay, so we are back, and I basically put a heatsink on here, as they say. This is not what they sent or recommended. I just found this laying around, so I put that, and Ethernet connected, and now I am going to connect the power, and you can see the power consumption on this camera at all times, hopefully. Let me make sure of that. So we have to wait for it to start booting. Okay, so the LED, green LED came on. That means it is booting. As I said, there is no HDMI or anything like that, so we are going to SSH into the box. Remember, this is industrial SBC. So let me open up the bash. Okay, and SSH 172.16.155, I think. I read that from my... Oh yeah, so the username is Debix, by the way. Debix, and the password is Debix. There you go. Okay, and I always drop to the root shell because I keep forgetting the sudo. Okay, so now we are in, and let's do a couple of quick tests, right? So the heatsink is here. Let's do a neofetch. Okay, so this image is Ubuntu 20 and the kernel is 6.1, and yeah, that's kind of it. There's not much else going on the screen. To be specific on the kernel, Linux i.MX 93 and Arch 64 and all that stuff. Okay, 6.1.22. Now let's do a sysbench and threads to CPU run. Just want to see if it gets toasty. Not even hot, forget about toasty. And the power consumption is 0.3, 0.4 amps. Okay, yeah, so that's 1600, so it's like 1 in 8, I think. So 10,500 ish is the Raspberry Pi divided by what we are getting, 1682, 6 times. Okay, 1/6 of Raspberry Pi. Okay, so it's 6 times slower than Raspberry Pi 5. Okay, let's do also a stress NG test. Okay, so results are back. Let's take a look at it. It's, wow, okay, that's low and slow. Yeah, so that's kind of expected from that CPU, but as I said, the point of this CPU and this SBC is not doing sysbench and playing 4K video. It's industrial. As I said, it can support -40 Celsius all the way to like 85 Celsius. So let's take a look at the Gpio. They said they have some command for it. They say just type Debix and --. Okay, so they have 2. Okay, so yeah, we're gonna test both. So the Debix Gpio. Okay, so Debix Gpio show Gpio name. Oh, okay. Oh, I like that ASCII art. That's nice. So this basically this way, right? If you flip it that way, so that's Ethernets are this way, and that's the Gpio, meaning this is the pin number 1. So the one closest to the Ethernet and to the edge of the board, that's pin number 1, and then 2, 3, 4, 5, 6, 7. That's how it goes. And these are the explanation of each port and the functionality. So we have a couple here green. I think I'm going to use one of those. Okay, let's hook up some of the cables and test out. So 1, 2, 3 from this side is ground. So let me do that. Okay, I want to keep the oscilloscope connected as well. So 1, 2, 3. Okay, and now we are going to use 3 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is going to be the first GPIO here. So 3, 4, 5, 6, 7, 8, 9. All right. So hopefully in this camera you can see both this multimeter and the oscilloscope. Okay, so what I'm gonna do is let's use this GPIO and let me run the command again. So it says this Debix GPIO and then the GPIO name, which is copy paste, and then we say out. Okay, mode is in or out, and the value is 1. Well, there you go. It's 3.3 and it jumped up on the oscilloscope. Okay, now if we do value 0, there you go, drop to 0. Okay, so that's nice. That's what I want to see. I hope every single SBC company out there just do this. It's not that hard, you know. They developed this app. Okay, what type of app is that? So first of all, which Debix GPIO, Debix GPIO, USR SBin Debix GPIO. Okay, so if I do file this, oh, that's a binary file. Okay, so that's some code they wrote in C and compiled. Hopefully they will publish the source code. That would be nice. I don't have it. It's not published. So anyway, what was the other one? Debix P underline PWM. So see, I don't like the inconsistency. Debix dash and now it's underline. Anyway, input PWM. I don't know. 0, 1, 2, 3. Nah. Okay. So help? No. Help? No. What's going on? I just want to generate GPIO or some PWM. Okay, so hold on. Which file is that? Debix PWM. Same path. Okay. You know what I'm going to do? I'm going to do what you may call a pro gamer move. I am just curious because I've never seen an ELF file like this, like a GPIO management. Usually it's like a Python script or something like that. I'm curious about both of these files and this one. So this one specifically because I couldn't even get it to run. So what I'm going to do is let me go to desktop and SCP Debix at 172.16.155 and the path is where's our bin sbin, sorry, Debix underline PWM, and copy it here, and password is Debix. Okay, so we copied the file. This is the binary file. Okay, and I'm going to do some reverse engineering magic because I don't have the documentation or anything like that. So give me a second. Okay, let's load it up in Ghidra and see what it does. Maybe we'll figure it out from there. Okay. All right, looks like the analysis is complete. Let me go full screen. The main. Okay, so in the main function, it exports to C, which is like 44 in decimal, right? And direction is, I think 1 is out, I guess, and the right's 1 to it. So exports the 44 GPIO and then writes 1 to it and makes it out, and then also exports 2D. 2D is one more, so it's 45, right? Yeah. And then also export 33, which is 51. Okay. So it exports 3 pins and sets them all direction to be out. Okay. So far, so good. And then it is looking for if the parameter count, so param underline 1 is basically argc. So we can even rename that to argc. Okay. So that's if argc, meaning arguments count, is 2, it checks if the second argument is on, and if it is on, it is writing 1 to the 2D pin and the 33 pin, which is 45 and 33 was 51, right? Yeah. Okay. If you set it to on, and if you set it to off, it will set it to off. Okay. So then if you pass the argument set, that needs 4 arguments. That means it needs another one and another one. So 2 more digits because also it is doing A to I. So it is converting the string to the integer and putting it to this, and then calls GPIO write run, whatever that is. Let's see what that is. Okay, so it opens the GPIO and based on the uptime and the downtime. Uptime is the 3rd argument minus 4th argument, and downtime is the 4th argument. So if we go back, basically 4th and 3rd and 4th. So it expects 3 additional arguments. Okay, so based on this, on, off, and set. All right, let's go back and 44. I believe the 44, let me see, that's going to be 1, 2, 3, 4, 5, 6, 7, 8. I think that should be it. Actually, let's test that theory first. So we ran the app, so it probably exported already. Let's see, ls sys class Gpio. Yep, there you go. So 44, 45, 51 is exported already. So the app did it. So let's do with the 45. Okay, so let's find the 45. Gpio 45 echo 1 to Gpio 45 value. There you go. Okay, so if I echo 1, that one is Gpio 45, and if I echo 0, that goes 0. Okay, now based on what we learned, okay, so what we learned is if you set the argument as you pass it with argument set, meaning if we do Gpio underline, what was that? Debix PWM set, that's the second argument, and then it expects 1 and 2 digits, and those can be uptime and downtime. So argument 3 should be more than 4 because it's doing a minus over here. So blindly, I'm just going to do that. I don't even know what the hell I'm doing, okay? That's the channel's name, by the way. So Debix PWM set and do 10 and 5 maybe. So it's going to be 5. Oh, look at that. Won't you look at that? Okay, so we did that. I don't even know what I did. I just was following this binary whatever. Okay, that was stupid lucky. I don't even know what I did, but yeah, it just worked. Okay, what is 10? What is 5? I didn't study. Okay, stop it. Oh, it stopped. Okay, the value is still 1, so it goes back to 3 volt. If I do echo 0, it will drop to 0. And if I run it again, let's this time do 2 and 1 maybe. Let's minus 1. I guess it's doing it. I am doing something. It is something. Yeah, the pro gamer move actually helped. Just I was able to get it from the binary. So yes, if you don't have the source code, you can always use Ghidra, reverse engineer the app from the pseudocode. You can figure out what's going on over here. So yeah, that looks like there's another argument called auto, and if you do auto, it goes into that input PWM thing that even if you don't run with auto, it does that. So I don't even know what that means. So yeah, it does the same uptime downtime thing and creates a thread based on that. But which pin? So let's try that one without any argument. Let's do Debix PWM with no argument. Oh, it jumped up. Okay, so I guess that's something. So let's say 3. Oh, it is doing it differently though now. You see, that's this, what? 3 and 5, I guess. 1, 2. Oh, so you see the timing is changing. So if we do, let's do it again. Let's start bigger, right? Let's start from 6 and then do 3. Now didn't change it. Okay, 1, 2. Yeah, so it is changing the timing of, so let me zoom back. Oh, just 1? That's just one signal, not continuous. That's just one time goes up and comes back down. Well, yeah, that one is not continuous. So you see the other one that I did, this one, you see that? That's magic. So mine is better than the auto one. So yeah, anyway. So I like this. At least they have some app. Although the documentation, I wish they had mentioned this. There is nothing related to this app or arguments in the documentation, but I'm sure hopefully they will improve the documentation. But yeah, so we got the PWM working. We got the Gpio working. I really like that Gpio thing, the app, whatever was it, Debix Gpio, and with the show Gpio name argument. Yeah, that's nice. I like that one. Yeah, so we got the, oh, iPerf. I almost forgot that. Sorry. iPerf 3 is P50 bidirectional 172.16.11. Oh, one side is good, the other side is not. Ooh. Oh, okay. So yeah, that's good. That's good. Yeah. Sorry, take it back. So yes, we are getting the gigabit that we are expecting. Just, I finished recording the other video as well, like 3 days ago, whatever. It was this one. What was it? Zemo board. Yeah. So I just finished Zemo board review, and then the Zemo board, if you haven't seen that video, go check it out. In the Zemo board, the gigabit is not really gigabit. It's like 880, but this one is truly gigabit Ethernet. So yeah, that looks looks like it's working fine. It's a little bit low spec, but based on the price, based on its audience and the target audience, which is like industrial users, I think, you know, they can appreciate the CPU because, as I said, that's like industrial CPU, and it does even have Enclave, by the way. That's something I did not even know. So like kind of like an HSM. If you don't know what HSM means, HSM is like hardware security module, I believe, and it's basically secure enclave like what you might have in your iPhone, or like YubiKey, or the professional HSM providers like Thales and other ones. Yeah, those are like HSMs that companies use to safe keep and protect their, let's say, RSA keys, AES keys, and so on. So yeah, those are secure enclaves where you can just store the device itself, will generate the key and will safe keep, you know, protect the private key. So you can never get the private key out. That's the theory. Can never get the private key out, but you can send streams of data and get it signed or encrypted. So this one does have something like that. Let me show you. So i.MX93 secure enclave. Yeah, so this is what they're calling edge lock secure enclave. So this is the i.MX9. So yeah, the CPU itself does have that, and seems like you can use that to store and generate, hopefully. There's a SDK, I didn't try that, i.MX3 example SDK. There was, yeah, here, yeah, this one. So this one looks like, you know, you can compile this. Give me a second, let me see if it is going to run on this device. First of all, is there a GCC? Yes, good. Okay. Okay, let's see if I can get this example to compile. So it says git clone that, cd that, and check out this branch. Why? Okay, anyway, let's do that. Whatever they are saying, I'm just gonna follow. Okay, I already have these, I think. I don't need, I'm gonna try without it. Let's see, let's see if it can compile the libraries. Oh, okay. So far so good. Yeah, seems like I didn't play around this, and it's going to be out of scope of this video, I think, honestly. But I just wanted to highlight that. Oh, it compiled. That's, yeah, that's nice. That's nice. So it seems like, yes, it compiled. Okay, so we compiled the libraries and everything. And they have like tests in here. HSM perf test. Let's see. Ah, I didn't install though. Let me see. Is there an install step? Yeah, libs install. Yep, this one. I didn't install it. Let me install it. Ah, don't compile it again. We just compiled it. Okay, wow, so it installed. Yeah, there you go, libelehsm. That is awesome. Okay, so let's go back to where the tests were. Okay, there you go, libhsm is right there. NVM daemon. I don't know what that means, but I'm not familiar with any of these things. And this is really out of scope of this video, but I just want to see if I can compile the test. Do they have a test? In a small test example here. Oh, testing right here. Okay, what is this? Oh, install tests. Okay, let's go back. Plat equals ELE. Let's do install tests. Oh wow, it did install it. So ELEHSM test, is it? Oh, where did it install? ELEHSM test and ELE. Hold on, where is it? Okay, it's right there. Okay, ELEHSM perf test libelehsm.so. That's already right there. Okay, so cp, let's copy .so to usr lib. Yeah, let's go like that. ldconfig. Oh, wait. I know it's not a symbolic link, but anyway, let's see. Okay, HSM open session failed. So we're running the binary, but it doesn't. Okay, ELEHSM test, just test. HSM open session failed. Anyway, it's out of scope. I don't know what the hell I'm doing. I didn't study, I didn't read anything, but so I got this far, you see, without even reading anything really. I just got this far. Okay, so there is an HSM in this thing, okay? And you can store private keys in this. This is industrial, as I said. And as you can see, the power consumption is like very low, 0.3, 0.4 amps. Yeah, I honestly like it. I had no clue that it is going to be this much documented. Although the PWM part, I had to reverse engineer it. There's no documentation on that, but ignore that part. Everything else looks great. And Gpio app and the HSM thing is here. I got this far. I compiled the tests, I compiled the libraries, I ran the samples. Although it wasn't able to establish the session, maybe this particular CPU or this SBC or something needs to change, but I got this far. So yeah, I just wanted to share this this awesome industrial SBC with you guys, and hope you enjoyed it. If you have any questions, please let me know, as always, down in the comment section. And thanks for watching. I will see you in the next video. Bye for now.